So our goal with some of those, if they're already subsidizing some of the testing so that they can prescribe drugs in countries, they should be screening first. What that will allow them to do is if they have that, maybe let's call it $100 million budget for a certain country, right? And that's for drug and screening,
Okay.
drug and NGS testing. We can now cut that number of NGS tests down by 80 to 90% so that they can run the 10 to 20% of the NGS on a very high likelihood population
Okay.
and save all that money on the NGS testing and allow more access to more patients.
Welcome to the People of Pathology podcast. I'm Dennis Strank. On this podcast, we explore pathology one story at a time and connect with the people behind the diagnosis. Sometimes the testing to get personalized treatment isn't available or it's just too expensive. So what if we had a faster, less expensive way to do it? Today, my guest is Travis Wold, CEO of Imagenomix, a company developing AI-powered tools to screen for mutations directly from an H&E slide. We'll discuss how AI may help identify patients who could benefit from targeted therapies and clinical trials more quickly. All right, let's get into this conversation with Travis Wold. Travis, thanks for being here with me today.
Yeah, thanks, Dennis, for inviting us. We really appreciate that and looking forward to chatting here.
I want to start with your background because it gives some really good context for everything else that we're going to talk about today. So let's start there. Can you tell us a bit about your backstory?
Yeah. So born and raised in Alaska on the fishing boats and part of the Indian Health Services growing up. And when you're young, you think free health care and it's all fine, right? My father ended up with brain cancer and he didn't get the necessary testing early or extensive one. And I had actually been early in oncology. Luckily knew enough to get him a little bit better care than what they were going to provide. But it really opened my eyes up to what is free healthcare and which populations are really missing out on the more advanced healthcare, like the cancer test mutational testing. So I've been with KRAS, Vericide, Myriad, so Circulogene, all these companies that can test for these mutations, but the reimbursement is anywhere from $30,000 to $12,000. And only a certain number of Americans actually have the right insurance to get that testing. The rest don't. 75% do not. The majority is due to insurance coverage or time. And so that's why I love Imagenomix and what we're doing here with the AI side. Not only can we address those, but globally, 98% of the population does not get this testing just due to cost. Forget about time. But with AI, that's going to be the future of opening up cancer mutational testing so that patients can get targeted therapies for their cancer.
Okay. There's a lot to talk about there now. So it seems like your personal experience with your dad and just kind of growing up, looking at what is, like you said, what is free healthcare really? At what point did you think, okay, I got to do something about this? You know what I mean?
Yeah. And some of it came when I started working with a lot of international countries. And I was with Circulogene at the time, and I was working with about 44 countries, different distributors. And they said, if you can just get the cost down of the NGS test to $1,000, we'll send you hundreds of, and we'll get ministry coverage, et cetera, et cetera. And we got 2 per week after 2 weeks, right? From 44 countries. And so they just said the cost is just too much still for the ministries. And they can't afford to do this on a mass abundance for everybody. So they'd set aside maybe a small budget that you have to fight for once a year for this type of testing, but they don't get this all the time. So when people say, man, if we could only live here for free healthcare, I was like, as soon as you have something serious happen, if it's a cancer, you're going to want to come back to the US, right? So that really opened up my eyes. And when I was talking to the founding team at NYU and they had these AI tests that they can do for $50, $100, that really opens up the world to potentially democratize a lot of this targeted mutational therapy cancer testing.
Okay. I like that, democratizing that kind of testing. Now, you were talking about the founding team. That was the Imagenomix team.
Yeah, and NYU Langone, Dr. Dan Oringer, Matthias Snuderl, and R.S. Sirgos. We're actually the first ones to ever come out with an EGFR test, right? They did this in lung with EGFR, KRAS, a few of the other point mutations, which is how they published in Nature in 2018, ended up getting the patents issued for this as well. Their thought process behind this was just the same as how can we find these faster, right? They weren't really thinking about the cost portion, but in clinical trials, 85% of the cancer clinical trials fail. All of that's almost due to time because a lot of the cost is subsidized. But can you turn this test around in a timely manner before I put a patient on therapy and exclude them from a trial? And average turnaround time for the NGS testing was about 28 to 33 days. So that's too long for some patients. So if we can screen these with AI in the first day where the H&E is made, and all confirmed cancer cases have a H&E slide global. That's the one concept where if we can scan these in on a scanner and do this for pennies compared to the NGS current testing method, that opens it up globally. And that's what got us really excited about this.
Okay, that makes sense. A massive reduction in cost. Yeah, that does sound exciting. I want to get into what Imagenomix really does and kind of, I guess, dissect this technology a little bit. But before that, there was this period of time where you were working in a lot of other companies. And can we kind of go through that a little bit? And then what were the problems that you kept seeing and that kind of led you to Imagenomix?
Yeah. It was a few things. So one of the beauties of liquid biopsy is there's a saying out there, the issue is with tissue, right? 26% of tissue samples fail. So patients are relying on this. You're waiting 28 to 33 days and the sample fails. And you're like, oh my God, this would have been a good patient for a targeted therapy. Wish we would have known those answers. So with Imagenomix, you can just screen that cancer stuff. And so that 26% number can drop down and you can test the right samples. We can also check for how many tumor cells or tumor tissues on that slide for adequacy so that we know whether we can run a big panel, 500 gene plus, or maybe we have to run a really small panel. All of that's now accessible off a single scan.
You mentioned tissue failure. Can you explain what that means?
Yeah. So you think about fine needle aspirations and it's a fantastic thing, right? You're going with a small needle.
Yeah.
A lot less invasive, a lot better recovery time, a lot less cancer material there, right? So as you go through the H&E stain, then the IHC stain, maybe it's done, right? You've confirmed the cancer, but you may not be able to do more tests. So by the time it gets to that NGS laboratory, they don't have enough tissue to run that testing.
I see. Okay. So it's used up in the cutting for the slides, right?
Correct.
Okay. I mean, I can relate to this because being a PA, grossing in these small biopsy specimens, whether they're FNAs or just other biopsies. And yeah, there's not much tissue there. And I sometimes wonder, like, how are we going to be able to do all these tests on this tiny piece of tissue?
Yeah. And we're not trying to replace NGS. We're not trying to replace pathology. AI's got a long time before it's going to be trusted as singular truth. So the way we view this is run as many of these as you can for an inexpensive price in lung and breast, which is where we're at now, in brain. And then for the ones that have that really high chance, 90 to 95% that they actually have that targeted mutation, run that NGS test. You can save a ton of money that way. You save a ton of time that way. And it assists the pathologist, the oncologist, the patient within the first 2 days as well.
Okay. So that's what Imagenomix does, right? Where you're using AI to predict these mutations from the standard H&E slide, right?
Yes, exactly. And we view all of these as screening tools right now, not diagnostic tools yet. Over time, with more studies, more experience, more validation, we'll start picking off one mutation at a time. And so that's another difference in Imagenomix compared to others is we're not trying to make big, broad panels of 100 to 500 genes. We're studying really one mutation at a time, probably the top 6 to 7 in breast and lung right now, and the top 3 in glioma for brain. And we go really deep on those to make sure we have the highest sensitivity specificity that we can get, or an accuracy that we think is very attainable in the next year to 2 years.
Okay. Wow. That's amazing. All right. So if for people listening who maybe they don't understand the computational pathology aspects just yet, can we go through kind of how this actually works, how it analyzes the H&E slide?
Yeah, it's a really good question. The models are trained to detect regions with mutations, which in theory you can call hotspots in H&E image. There's a slide that all tissues put onto. all cancer laboratories do an H&E
Yep.
stain, right? And from that, we scan it into a scanner. And then from there, we upload it into the Imagenomix platform and we run our software algorithm where we start looking for these hotspot mutations, quote unquote, TP53, KRAS, EGFR. So we can really train our models to detect these specific hotspot mutations. So we highlight these image tiles with scores trained by these models, right? And so the models aren't just put in and you look at cancer slides. We actually have to go look at NGS truth because that's the gold standard. So we say, great, we take 1,000 or 2,000 EGFR samples that have been tested. We match up those slides and then we run our algorithm on those. So it starts to learn what an EGFR pattern looks like. Then we do that on KRAS, then STK11. So we just keep repeating that pattern and then tweaking our algorithm based on what it's seen and where we think we need to adjust.
I'm curious how, like you're talking about EGFR, KRAS, how do we determine which mutations you're going to start with? Are they just the ones that are going to have the biggest impact, or how does that work?
Yeah, good question. So the way that the first concept came out is Mattia and Aris were in Mattia's lab and he was looking at slides as they were chatting about projects and he goes, I think this is an EGFR. And Aris, who's the AI guy, says, well, that's interesting. How do you know? He goes, well, I've seen so many of these and I created a panel and I've been trying to match these up. I just think this is EGFR based on my experience. And Aris said, that's great. Let me see if I can create an AI. Because if you can do that, but you don't know what you're looking for, maybe AI can pick this out and do it better. And that's how Imagenomix was born, off that singular conversation saying, I think my AI model can do this better than what you can do. So then they went into lung, looked at all the common mutations, and then we published Nature 2018 and then patented that process.
Okay. And you said you've also branched out into glioma, right?
Yeah, so glioma was their passion project. So Dan Waringer is a neurosurgeon. Mattia is a molecular pathologist specializing in brain as well. And so we tend to look at right now in gliomas IDH1 and 2. There's no real good IHC test for IDH2 right now. And there's a lot of co-mutations or variants in IDH1 that can't be picked up with IHC yet. And IHC is the screening tool to get the NGS confirmation right. That's the way it's done. There's also not a lot of neuropathologists in the nation. There are some states that do not have a singular neuropathologist. And so the way we view NeuroPredict, which is what we call our glioma test, is we can run these and see if those IDH1, IDH2s are present. What that does is there's a couple companies that actually already have targeted therapies for this, but they miss about 50% of the patients nationwide, not due to bad tests. It's just there's a lack of tests in a lot of the regional hospitals. Like academics, you're probably going to get the right care, right testing, et cetera. There's still a gap missing with about 15 to 20% that they can't test for. With our testing with NeuroPredict, we can actually pick up almost all these IDH1, IDH2s right away.
Wow, that's amazing.
Yeah, it's really neat because you compare that to MGS and now you have this tool that, for 50 to $100, you can run on every single one of these patients versus an IHC and get as accurate, if not more accurate results. That's the first one we've really seen that could replace an IHC type of screening tool.
Okay. That's I think a really important use case then, right?
Yeah, because when there's nothing, like no IHC for IDH2, what do you do?
Yeah.
And so when we've created this AI test that can pick it up with a 95% certainty, that's better than a lot of IHC currently even on the market.
Yeah, that's true. Interesting. We're talking about using AI in pathology. And these days, while AI is used a lot, it's a bit of a bad reputation in certain areas. Yeah. Now, when you're talking about AI in pathology, people are thinking about efficiencies and workflows and image analysis and annotating whole slide images and stuff like that. And what you're doing is something different, I think. And so when you're explaining this to pathologists, oncologists, how do you make sure they understand how it's different? Do you know what I mean?
Yeah, different from what, I guess, because there's a lot of conversations that happen on the differences.
This is specifically for the mutations, right?
Correct.
All right. And how do you get that across that it's specifically for that?
Yeah, it's a good question. So a lot of people are trying, there could be hundreds of these AI companies like
Oh yeah.
this. There could be so many, and you know this being in pathology for so
Yeah.
long. There's so many companies answering singular questions or a few questions. And right now with AI, very similar. Like we're doing some mutations and we're just sticking to that right now. And we're going very deep on that science and only concentrating there. We get all these asks for all these projects on IHC and cell counting and all this.
Mhm.
A lot of companies are already working on them, right? We just want to be singularly focused on driving down the cost of AI mutational analysis so that people get to right targeted therapies. 75% of the US doesn't get it, 98% of the world doesn't get it. There's a huge cap missing.
Mhm.
That's our passion. So we want to stick right in that realm of just helping on the mutational analysis for right now.
Okay. I like this because like you said, there's a lot of companies working in AI and pathology and they're trying to do everything. And you're trying to just stick to this one area and do the one thing that you're the best at.
Exactly.
Yeah, I like this. I like this a lot. This is the People of Pathology podcast with our guest, Travis Wold from Imagenomix. We'll be right back. When it comes to cancer staging, one of the most important parts is finding all of the lymph nodes. I should know. It's what I do every day. Yet this process has remained the same for over 100 years, manual, tedious, and time-consuming. That's a problem because every missed lymph node can mean inaccurate cancer staging. That's about to change. Enter InVision from Cision Vision, a first-of-its-kind device that's redefining the standard of care. Traditionally, we identify lymph nodes by sight and feel alone. InVision changes that using short-wave infrared technology to make lymph nodes stand out clearly from surrounding fat and in real time. In its first 104-patient study published in the Journal of Clinical Pathology, InVision helped increase lymph node counts in 86% of cases and even upstage 4% of patients from N0 to N1. I personally contributed to this study, and let me tell you, seeing the technology's impact firsthand was amazing. It's time to invest in grossing innovations that improve patient care. So, how is your lab approaching innovation in grossing? Book a demo at demo.cisionvision.com and start seeing lymph nodes like never before. Are you thinking about applying to a pathologist assistance program and feeling a little lost? That's why I created the Path to PathA, your PA school application blueprint. This is a step-by-step prep course that gives you everything you need for a strong application. From finding shadowing to writing a standout personal statement to prepping for interviews, this course was made to help you feel informed, confident, and ready. Visit www.thepathtopatha.com to join the mailing list. You'll be the first to hear when the course launches. Your path starts here. And now for the rest of my conversation with Travis Wold on the People of Pathology podcast. Let's start talking about clinical trials because you mentioned this earlier. A lot of clinical trials fail. I think you said, did you say 85%?
85%
All right.
on average fail in the cancer world.
Okay, let's talk about this. First of all, why does that happen? Do we know?
Yeah, so it's not really a cost factor because they're being sponsored, but it comes down to time is number one, and then lack of tissue is number two. Remember, 26% of these samples failed from quantity not sufficient, QNS, not enough cancer tissue there, right? That's the first problem that will help solve. The second problem we're going to help solve is speed, right? The day that H&E is made, Imagenomix can tell you whether you have a high likelihood of that mutation you're looking for or not for a low price. So think about 1,000 patients that need to be screened with NGS, the old rate, $5,000 per test. Let's call it that because I ran into a contract like that recently with a biopharma. They're at $5,000 times 1,000 that they would have to run to just be a screening tool for end result. Or for this, let's say it was an EGFR or KRAS project, we can rule out 85 to 90% of those, or 850 to 900 of them that do not have that mutational status. So run them on the 100, and you can do your full panel NGS if you want to, or you can run a rapid PCR or a small panel NGS if you're just trying to confirm those mutations. And you can do that in a couple of days. You can do a PCR for $50, right? You can do a small panel NGS for a much lower cost. And NGS companies may not like that portion, but you can get that patient answers within a week versus 2, 3, 4, 5 weeks. And that's the power of how AI will start integrating in and not replacing everything, but helping improve that workflow, like you said earlier. I see this instance where this should be done on almost every lung and breast cancer case, probably by next year. Just screen all of these with high prevalence likelihood, high screening tests, whether it's us or somebody else, for a low cost, and then reflex into an NGS panel, whether it be a small panel, big panel, because that's the confirmatory test. That's how you start bringing trust to AI. A lot of companies say, we're replacing MGS and we're replacing pathology and whatnot. We're saying, no, let's just make it more efficient, right? Those tests are really dang good. We're just solving the time and cost portion and the loss of tissue. Let's start there. Let's see how high the AI accuracy can get for trust. And then let's revisit to see if it can replace NGS and some of these confirmatory tests that we know are very good and predictive.
This makes a lot of sense to me. So the time aspect, and I think like cost, it sounds like they're both very important to you. And the time aspect, like you're talking about getting people results within a week. So they're still within that, hopefully within the window to get into the clinical trial, right? That's the idea?
Yeah, exactly. Because otherwise they're waiting up to 35 plus days,
Yeah.
right? And patients are like, hey, I just want to be on therapy now. I don't want to wait for the result. And let's say they want to go on the clinical trial and the tissue sample fails and they need to run it again. That takes another week, 2 weeks. Then you got to bring the patient back in, talk to them about the trial and enroll there. That takes even more time. So the sooner we can get this targeted therapy answer with the mutational status, the better.
Okay. I like that a lot. That's a really good focus. And speaking of focus, now another big focus for you, and you mentioned this a little earlier, underserved populations and countries where this kind of molecular testing isn't available or is way too expensive, like you mentioned.
Yeah.
Now, how do you see something like Imagenomix helping to close that gap?
Yeah. So this is going to take longer on all fronts. Somebody's got to pay for it, whether it's the ministries or pharma.
Mm-hmm.
So that's going to be a longer discussion, but I know pharma is subsidizing some NGS tests now. So our goal with some of those, if they're already subsidizing some of the testing so that they can prescribe drugs in countries, they should be screening first. What that will allow them to do is if they have that, maybe let's call it $100 million budget for a certain country, and that's for drug and screening,
Okay.
drug and NGS testing. We can now cut that number of NGS tests down by 80 to 90% so that they can run the 10 to 20% of the NGS on a very high likelihood population
Okay.
and save all that money on the NGS testing and allow more access to more patients. Because you only have a certain amount of patients that end up getting the NGS test because of the budget.
Okay. Yeah. Got it.
So now we can expand that budget for those countries. For the ones that aren't getting it, I spoke to a pathologist in Argentina who was part of the Digital Pathology Association. And I did a talk out there in San Diego last year and asked him, I was like, how many NGS have you run? He goes, 0. I was like, we 0. Like, what do you guys can do? Because we don't know. That's why I came here to see if we could figure something out, whether it's AI or screening or something.
Was just because they didn't have it or they didn't have the money to do it? Do you know?
They don't have the money to do it.
Okay.
You think $100,000 scanner even?
Yeah.
Then you think about the NGS, not only just the equipment at $1 million, $2 million, the upkeep of it. How much does it take to upkeep an NGS laboratory? It's pretty dang expensive. And then who's going to pay for all the testing, reagents, et cetera? That's their ministry.
I see.
And that's their country. So they want to do this, but how do they pick the right patients to do it? Is it family and friends and relatives? Is it the rich people only? Who should get this? And so
Right.
that's where at Imagenomix, if we can start to bring in these lower cost screening tests, and hopefully eventually they become diagnostic because they have enough data to get to the NGS level, that'll open up the entire world where you're democratizing who gets tested and who doesn't, where income status or where you live won't matter.
Mm-hmm.
But we're not quite there, to your point. So for these countries that could have a budget like this, AI will open all these up because you can run an inexpensive screen. Now you know, hey, this patient has an 80-90% chance of having this mutation. Let's run a confirmatory panel, whether it be PCR or NGS. That way, that patient is available or has the option of targeted therapy. Now, that'll be up to pharma and their country and their whole negotiation on pricing, on how that goes. But by the next year, we will have screening tools available to every one of these countries just via our portal, where they can upload their cases that they think maybe have a mutation or they want to know whether it does. And they're a candidate for that targeted therapy if they're flagged. That'll all be available starting next year, probably by the end of this year.
I love this. I love this. This is, it's a breakthrough, really. I mean, you're making this kind of testing available to, I guess, everyone who needs it, right? We're trying to do that at least.
Yeah, exactly.
Yeah, this is great. All right. Now let's talk about partnerships, because I know Imagenomix is partnering with Proscia, with PathPresenter.
Mm-hmm.
And I'm curious, like, how did those partnerships start to happen? And then let's get into, like, you've got this technology, you're partnering with these companies and you're bringing it into the world. And how does that work?
Yeah. So the way we kind of view them is they're both excellent image management systems, and they need more apps. So think of them as like the iPhone, and we're an application on the iPhone. Right?
Oh, okay. Yeah.
And right now, Proscia, PathPresenter, Philips even don't have a lot of these apps yet. What they had is a whole bunch of slide images, which makes them very broad, right? They're like, we have X amount of lung cancers. We're like, great. What data's on those lung cancer slides and images? Like, I don't know. We could run NGS on all of them and spend a lot of money figuring out what's on there. And why would they want to do that? They want to drug discovery, clinical trials, letting pharma know how many of these mutations they have, where they came from, right? There's a lot of information that can be extrapolated when you know a lot of that mutation data. But they don't have that. So how do they test all of these? That's a pretty big budget when you're talking about thousands of dollars from NGS. Same story. You can screen them all with us, figure out which ones have a really high likelihood of the mutations you're chasing, and then you can run that PCR or NGS. And so you build up your data that's all breadth at the time, a lot of lung cancers. And now you can say, hey, we have 10,000 EGFR, we have 9,000 KRAS, we have 15,000 STK11, et cetera, et cetera.
Yeah.
Now they know their data. And now they know where it came from too. And they can start figuring out, okay, why is there such a huge EGFR positive population here, but a big KRAS population here? So a lot of that data will start coming out as AI is starting to use more and more, not only city to city, but country to country, right? And so now you start opening up where the right drug should be and who the right people should be to get those.
Okay. I love this a lot. All right. So I want to end with this. So we're talking about you're doing this mutation testing, and then eventually possibly reducing the NGS testing because you only need it to confirm high probability cases. So that's going to reduce that amount of testing. It's going to reduce cost. If that starts to happen, where do you think this could go? Like 5 years, 10 years? What do you think we would be looking at?
Yeah, so 5 to 10 years is a good way to frame it. So let me rewind, because there's a couple of things. NGS can do these 500 gene plus panels. They can do TMV. They can do a lot of co-mutations. There's a lot of great information on NGS where AIs can take a lot of time to catch up.
Okay.
Because to get really good at singular mutations, we've got to study singular mutations, lots of them too. We get different staining slides. We get different colors. We've now created our own normalization techniques at Imagenomix that we're patenting as well. But so there's a real valid reason to use NGS on a lot of these cases. Even if we don't flag something as positive, there's still some good reasons to use NGS. So let me caveat there.
Right.
But
okay.
Over time, as AI starts to learn and get more and more of these samples scanned through and run, and we start getting more broad on our panels, there could be a lot of NGS that's replaced in the future, but it'll take a lot of time. I know AI is moving fast, but in the medical community where you need a very high percentage accuracy, this is a 5 to 7 year window, which is not a long time, but the way AI is moving, it is a long time.
Sure. Okay. That makes sense. This is a interesting view for the future. And like I said, the work that you're doing, reducing costs, especially, and democratizing this accessibility to testing is amazing. I love this a lot.
Yeah, thanks, Dennis. We're super excited. Our value, the mission statements here is you should not have to think about how much money you have, where you live, what insurance you have, right? You should just be able to get this type of targeted testing because there's so many good targeted drugs out there.
Yeah.
And they're not being used to the full extent they could. In IDH1 and 2, glioma, which is one of our passions, like we know about 50% of the population just in the US is being missed. I don't even know what that is globally. Maybe it's 98%, maybe it's less because it's brain, but it's not, the brain's not a thought about type a lot of times, right? I met with a couple of foundations and they brought me the data that 52% of gliomas are not being tested and they're not being offered targeted therapy right now. Right.
Wow.
And so we have a simple screening tool that can screen all of these patients to allow them to be on this targeted therapy. And it matters for them because they get another about 12 months of life. That's the power of targeted therapies.
Sure.
Is they're really good at fighting these mutations causing the cancer to replicate. Let's just find more of them and let's make it accessible to everyone. That's our goal. We're not trying to fight anybody or do anything. Let's just make targeted testing more accessible to the masses.
Love it. Love it. That's a great message. Travis, it's been a super interesting conversation and this technology is fascinating. Thank you very much for coming on and talking about it. Travis Wold, thank you.
Yeah, Dennis, thanks so much for having us. And we really appreciate your work.
If you're looking for another episode of the People of Pathology podcast to check out after this one, here's a clip from my interview with Yair Rivenson as he talks about how Pictor Labs is developing virtual staining technology.
Then you could go and put it on saying, okay, here's what this block has. Here's what this block doesn't have. Which drug programs does it fit? And all of a sudden you get a completely different view of how you can use a tissue block, because again, you create some sort of it's very fashionable to say digital twin of the block, and that digital twin is really becoming that asset that you can run all these different hypotheses, and it's all in silico. So again, you just don't run through it. And once you understand what is the best fit, what's the best hypothesis, you can just run with it. Yeah, this is one of the most interesting value proposition, again, from patient perspective and from biopharma perspective.
You can hear the rest of my conversation with Yair Rivenson in episode 223. All right, big thanks to Travis Wold. Goal of Imagenomix is to use information that's already present on the H&E slide to identify patients who are most likely to harbor actionable mutations. Rather than replacing molecular testing, the idea is to create a rapid, low-cost screening tool that helps determine which patients should move on to confirmatory NGS testing. This could reduce unnecessary testing, conserve tissue, lower costs, and speed up treatment decisions. We discussed a challenge that receives little attention: clinical trial enrollment. Cancer trials frequently struggle to identify eligible patients quickly enough, and tissue requirements can create additional hurdles. By providing faster results, Imagenomix could help researchers identify candidates more efficiently and potentially accelerate enrollment into studies evaluating new therapies. The statistics that Travis gave here were surprising. I didn't know that so many clinical trials fail due to lack of enrollment. Technologies like this one could help alleviate that problem by making testing faster and less expensive. Perhaps the most compelling aspect of Travis's vision is the focus on access. Throughout the conversation, he repeatedly returned to the idea that a patient's geographical location or financial situation should not determine whether they receive potentially life-saving diagnostic information. That's a goal that resonates well beyond pathology. I think some of that comes from Travis's own background. The idea of democratizing access to the best treatments is a noble mission. And sure, it will probably have regulatory and even legislative hurdles in different countries. But providing the best care for the greatest number of patients is something that we should all be striving to do. Another topic we discussed is tissue failure, or basically not having enough tissue to run all the tests that you need to run. As a PA, this one struck a chord with me. In the days of trying to do more with less, I'm sometimes surprised by how little biopsy tissue we receive compared to the amount of information we need to get from it. Imagenomix can help to solve that problem so that patients who are depending on these results won't have to come back for another procedure due to tissue failure. These are exactly the kind of conversations that we need to be having as AI becomes more deeply integrated into healthcare. Whether you're excited about AI, skeptical of it, or somewhere in between, it's impossible to ignore the potential positive impact these technologies may have on patient care in the years ahead. This will be a fascinating field to watch in the near future. As always, I'll have links in the show notes to everything that we talked about today. Don't forget you can follow this show at People of Path on Instagram, or you can just connect with me on LinkedIn. Thanks for continuing to share the show with others. Together, let's inspire the next generation of pathologists and laboratory professionals. This show is a member of Health Podcast Network. Thanks for listening. I'm Dennis Strank, and I'll talk to you next time on the People of Pathology podcast.